Picture an electric eel. For over 250 years of scientific observation, that picture has been of a solitary creature, a lone hunter navigating murky water with its own biological radar. It was considered a fundamental truth, an animal defined by its isolation and its singular, shocking power. But in 2021, in a remote Amazonian river basin in Brazil, researchers witnessed something that completely upended that truth. They saw not one, but dozens of eels working together. This wasn't an accidental gathering. It was a coordinated, social hunt, a behavior never before documented and thought to be impossible for the species. The stage for this behavior is a small, deep lake connected to the main river. During the dry season, small fish called tetras become trapped here in high concentrations. This abundance seems to be the trigger. The hunt begins with a large group of eels, sometimes over 100, emerging from the depths. They work to herd the thousands of tetras from the deeper parts of the lake into the shallower water. The eels form a massive, contracting circle, a living fence that slowly pushes the panicked prey into a dense, swirling bait ball. The entire operation is silent, fluid, and deeply unsettling to watch. But how do they coordinate this without sound or sight in turbid water? Electric eels constantly emit a low-voltage discharge, creating an electric field around their bodies. It's their navigation system, a way to see the world by interpreting distortions in this field. During the hunt, this ability is used collectively. The overlapping fields of dozens of eels effectively create a massive three-dimensional sensory net. Each eel can feel not only the location of the prey, but also the position of every other eel in the pack, allowing for intricate, synchronized movements in near total darkness. Once the tetras are packed into a solid mass, a smaller subgroup of eels, the hunting party, peels off from the main circle. These 2 to 10 individuals approach the bait ball together. And then they do something incredible. They simultaneously switch their output from low-voltage navigation to a high-voltage attack. It's a single, coordinated blast of bioelectricity. The timing is precise. A slight delay from any member would weaken the collective impact, but they strike as one. A single electrophorus voltae, the species observed, can produce a discharge of up to 860 volts. This is the strongest of any known animal. Now, imagine 8 of them discharging at once. The water itself becomes a weapon. The overlapping electric fields create a zone where the voltage potential is so immense that fish are stunned instantly. They leap from the water, completely immobilized, and rain back down onto the surface. The eels then calmly swim through the aftermath, swallowing the incapacitated prey with ease. The efficiency is ruthless. This level of coordination begs a question: are they communicating? This isn't the simple, instinctual cooperation of an ant colony. It's a dynamic hunt with distinct phases requiring different actions from different individuals. The leading hypothesis is that they use subtle variations in their low-voltage electric pulses to signal intent. A change in pulse frequency or duration could mean tighten the circle, prepare to strike, or join the hunting party. They are, in essence, having a conversation written in electricity. This discovery forces us to reconsider what solitary even means. Perhaps electric eels are not solitary by nature, but by circumstance. In the vastness of the Amazon, prey is usually scattered, making lone hunting the most efficient strategy. But under specific conditions, like the trapped fish in that lake, a different, latent behavior emerges. It raises the possibility that many animals we label as loners might possess a complex social toolkit, waiting for the right environmental key to unlock it. It suggests that sociability might not be a fixed trait, but a flexible strategy.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.